Satyabama Institute of Science and Technology.
I'm Jesintha, Assistant Professor from Department of Computer Science in Satyabama Institute of Science and Technology. Today, I'm going to talk to you guys about computer vision. Let's start with what is computer vision. Computer vision is a field of artificial intelligence. But what does it do? It teaches computer to understand images, videos, and other visual inputs. And after it does that, it extracts meaningful insights from the image and makes the computer make decisions based on those information extracted from the image. So the goal is to have the computer visualize and understand and perceive the world as we humans do. So how do we do that? How does this all work? It starts with something called as image acquisition. The way we start looking is we see with our eyes. So the same way, the computer starts by getting insights or inputs from sensors, cameras, or other input devices with which they capture the images. And once it's done capturing, it converts the images into a digital format. This digital format is essential for the computer to understand. This digital format is numbered pixels, which makes the computer processing much more easier. And this is the most essential input and the starting step of the entire computer vision process. So the next step we have is called as pre-processing. The real world images are mostly blurry sometimes. It could have random brightness patches here and there. It could have random darkness patches. It could have contrast issues as well. So to avoid this, we do pre-processing. These things, these artifacts in the images makes image processing difficult. So we do pre-processing to enhance the quality, to remove the imperfections in the image, thus making it a standard quality for further processing. Once we're done with pre-processing, we go into the next step called as feature extraction. Feature are essential unique characteristics of a processed image. So these unique characteristics describe a meaningful property or meaningful points in an image. It could be an edge, it could be a corner, it could be a blob, it could be a texture, or it could even be a shape. So after finding out these unique characteristics, we go into something called as segmentation. This segmentation divides the entire image and its components into distinct regions or objects. Grouping these and assigning unique pixel values to each of these pixels in a particular segment makes it essential for detailed analysis of specific parts in an image. So once we're done with segmenting essential parts of an image, we go straight into something called as recognition. What is recognition? As the name says, it is to understand what it says. So once we identify the individual objects, we have to do image classification or image detection. What we basically do is we match up whatever we have observed in the image with the models we have practiced and learned so far and find a perfect match that matches with the one we have in the image, and thus understanding or labeling the object in the image with the model name. Sometimes we can also use object detection to find the exact position, thus giving us the general idea of what exactly the entire image is talking about. So to summarize the entire pipeline, we start with an image, we pre-process the image to remove uneven brightness, uneven darkness, and to enhance the contrast. And then we do feature extraction to find unique points. After that, we segment the image to find the necessary details, and then at last we recognize the components or the objects within an image and come to an understanding. So what happens at the end? Once we understand what the image is actually all about, the computer vision enables the machine or the computer to do the corresponding action that it's supposed to do. Let's take, for example, your face scanning application or your face unlock mechanism in your mobile phone. It starts with image. When you pick up your camera and your camera captures your face. And then it does pre-processing to reduce or to enhance the image to make sure that the image quality is good. It works even if you are in the bright area. It works even if you are in a dark room, right? So it does the pre-processing there. Once it's done with the pre-processing, it extracts your features like the way your face, eyes, nose, and everything is positioned. And followed by that, it segments your face from your background and it matches your face with the model it already has set up in the mobile phone, and the action does is your screen gets unlocked. Let's look at some of our applications of computer vision. Face unlocking in smartphones, the one we saw in the previous slide. Self-driving vehicles like Tesla uses computer vision. Automated checkout in stores like Amazon uses computer vision. Google Lens, reverse engineering of images in any chart applications uses computer vision. And medical imaging like detecting of tumors or any other inconsistencies in your reports. And surveillance and security to monitor traffic or to monitor any building security uses computer vision as well. And that's all for computer vision introduction, guys. Thank you.